Hello and welcome to section 5.5, which is on indirect proofs. So indirect reasoning is all possibilities have to be considered and then all but one are proved false. An indirect proof is a proof involving indirect reasoning. It's also called proof by contradiction. How you're going to write an indirect proof? First of all, you need to come up with a temporary assumption, the opposite of what you want to prove. And then you're going to show that that temporary assumption leads to a contradiction. So in other words, you're proving that it's false. And then you're going to conclude that the temporary assumption must be false and that what you want to prove must be true. So you're kind of working your way backwards through it. You're proving that something is false in order to prove that what you want is true. It's a backwards way of thinking about it, indirect. So suppose you want to write, for this example, you want to write an indirect proof of each statement. As the first step of the proof, what would you assume? So the statement is, at least one pair of shoes you bought cost greater than $25. So if you look up here, you need to state as your temporary assumption the opposite of what you want to prove, right? So then for my assumption, I'm going to say that no shoes cost more than 25, because I'm supposed to prove that one cost more than 25, so the opposite of that would be that none of them cost more than 25. That'd be my first step in trying to indirectly prove that statement. Another example, which two statements from this example right here contradict each other? So go against each other, prove each other. They can't both be true, in other words. One of them proves the other one false. So statement A, triangle XYZ is acute. Triangle is scalene. Probably should have put XYZ in there. Triangle XYZ is scalene and triangle XYZ is equiangular. Equiangular means all the angles are equal. So, can a triangle be both acute and scalene? It sure can. Scalene just means three different sizes of angles, three different sides. Three different sizes of sides. No sides are the same. No angles are the same. So those two can go together. An equiangular and acute can go together because an equiangular triangle would be 60, 60, 60, and those are all acute, so that would go together. Can you have none the same and all the same? No. So B and C are contradictory because a triangle can't be both scalene and equiangular. You can't have all three equal angles and also have all three angles different. That doesn't work. So then for my next example, I have an actual indirect proof here and how you go through it. So my given information is that 7 times x plus y equals 70. And I'm also saying that x cannot equal 4. Okay, for here, you cannot plug 4 in there. So then I need to prove that that's not supposed to be a 7, that should be y. Y does not equal 6. Okay, well, if you think about this, if I'm plugging 4 in there, y would have to be 6, right? So if I'm saying x can't be 4, then obviously y can't be 6, but I need to go through the thought process here of how I'm going to prove that. So I'm going to assume, since they're telling me that y can't be 6, I'm going to assume that y is 6. Okay? You're going to assume the opposite, the negation of it. So I'm going to assume temporarily that y does equal 6. That means I'm going to plug 6 in. So then 7 times x plus 6, because I'm assuming y is 6, equals 70. I'm going to go ahead and solve it like I normally would. I'm going to divide both sides by 7, because I can't do inside the parentheses first, so I got to divide by 7 both sides to get rid of it. So I would end up with x plus 6 equals 10, and then I'm going to subtract 6 from both sides. So x would be 4. And here I'll write that out quick just so you can see what I'm doing. So 7 times x plus 6 equals 70. I'm going to first divide by 7. Then I have x plus 6 equals 10. And if I minus by 4 there, I end up with x equals whoops, I was supposed to subtract 6, x would equal 4. Which is what I said right there. So, x equals 4. Well, look what I set up here in the given, x can't equal 4. So, but this contradicts it. It contradicts the given statement of x does not equal 4. So the temporary assumption that y equals 6 led to a contradiction. So we can conclude that y cannot equal 6. So I had to start by assuming the opposite of what I wanted to prove, and then go through the steps to prove that false, right? That it would have to not equal 6 by the work that I give. So bring this information with you, and we'll talk about it more the next time I see you. Have a good night.